Okay, welcome back. What we're going to do is we're going to learn how to divide some polynomials. This is super helpful whenever we're talking about some of the calculus principles. You've got to know how to do this before we go further. So I've got a function a that's dependent on x and a function b that's dependent on x. Function a is pretty nasty. Function b is just a cubic function. And I'm trying to simplify the division of the two. So if I write this out, I've got negative 14x to the 7th plus 8x to the 5th minus 6x to the 4th plus 5x. That's what a of x is. And I'm dividing everything by x cubed. If I only have a single term in the denominator, what I can do is break the fraction up among every plus sign and subtraction sign. So what I've got here is 14x to the 7th divided by x cubed plus 8x to the 5th divided by x cubed minus 6x to the 4th divided by x cubed plus 5x divided by x cubed. Okay, so what I've got here is I've got that 14x to the 7th divided by x cubed. They have the same base, but different exponents. So when I do that, I pick the largest number out of the two, which in this case is 7, and I subtract the smallest number, which is 3. So 7 minus 3 is going to be 4. Keep the coefficient, the number in front of the variable, and I've got x to the 4th. Excuse me there. And then over here, same process. Bigger number is 5, smaller number is 3. So I'm going to have 8x squared minus 6. 4 minus 3 is x. And over here, 5x over x cubed. Since 5x, if this number isn't larger, in this case, we're going to call that the remainder. You can simplify it further than that, but for this case, what I wanted to do was show you what q of x plus r of x over b of x form looks like. So my remainder here is 5x, so that's my r of x. B of x goes on bottom of the remainder. And the quotient is the thing I get back from dividing all this out. You could have done the same thing with polynomial long division, and that's what we're going to do next because this one's a little tougher. So bear with me. Let's say I've got a of x is equal to 8x cubed plus 35x squared minus 17x minus 5. And my b of x, instead of being a monomial, is going to be a quadratic. So I've got x squared plus 5x plus 3. So earlier what I did, since I had a monomial, is I split the x cubed up among every term. In this case, I can't do that. So what I've got to do, if I'm going to divide a of x by b of x, is I've either got to use some sort of method that other people have invented. There's several methods, and there's one preferred method that I like to use. So the preferred method that I love to use is polynomial long division. It's the first way I saw it. It's the way I'm going to teach it here. So I've got 8x cubed plus 35x squared minus 17x minus 5. I'm dividing all these numbers, all these variables and coefficients by x squared plus 5x plus 3. And I always look at the leading term and I finish when I get to the lowest term. Whenever x squared is larger than the remaining powers on these variables. That'll hopefully click here in a second. So how do I get from x squared to 8x cubed? Well, I need a coefficient of 8 because the coefficient on x squared is 1. 1 times 8 gives me 8. X squared times something gives me x cubed, which is x. So 8x times 8, 1x squared is going to give me 8x cubed, and the whole goal is that I get rid of that guy, right? The implicit operation in division is subtraction. Once we're done here, I'm going to subtract all these terms. So I've got 8x times that, so now I've got to multiply 8x by all the remaining terms. So 8 times 5. 8 times 5 is going to give me positive 40. X times x is x squared, so those are like terms. 8 times 3, that's going to give me 24. That's 24x. Okay, but I'm subtracting all these. So when this negative is on the outside, it means it distributes to each term. So I'm subtracting 8x cubed, subtracting 40x squared, and subtracting 24x. So in that case, I've got 35 minus 40, which is negative 5x squared. 8x cubed and 8x cubed here, they match. Negative 17 minus 24. So you can see if I have the same sign, all I have to do is add across and keep the sign. 7 plus 4, it's 11. 111, 112, sorry. Negative 41. So I've got negative 41x there. Minus 5. Okay. So since x squared and x squared match here, I've still got to repeat the process until this degree is higher than any degree here. So since x squared and x squared are the same degree, I have to keep going. So what number can I multiply 1 times x squared by to get negative 5x squared? 1 times negative 5 gives me negative 5. And then the x squared is the term that I want. So that's just going to leave it as a constant. So negative 5 times 1 is negative 5 x squared. Negative 5 times 5 is going to give me negative 25x. And then negative 5 times 3 is negative 15. But remember, I'm subtracting, so I'm going to add the opposite. And so what this gives me is positive 5, positive 25, and positive 15. So plus 10. I'm doing 41 minus 25 and switching the signs. So 11 minus 5 is going to be 6. 3 minus 2 is 1. So that's negative 16x, right? Negative of a negative is a positive. And then negative 41 is larger than positive 25. So the difference between the two is 16. Here, negative 1 times negative 1 is a positive 5x squared. So negative 5x squared plus 5x squared, they're going to cancel out. Okay, so since this guy has a degree of 1, that degree is actually smaller than x squared. So in this case, this is my remainder, or my r of x. Up here, this guy is my q of x, and this guy is my b of x. My quotient here, b of x was what I started to divide by. So a of x over b of x is equal to the quotient, which is 8x minus 5, plus negative 16x plus 10 over x squared plus 5x plus 3. All right, that is it. Hope that helps.